Hi everyone, welcome to the lecture on microprocessor and microcontroller, the first lecture series, Introduction to Microprocessor. Myself, I am Magesh Kumar, a faculty, Department of Electrical Electronics Engineering, Hindustan College of Engineering and Technology. In this session, we will talk our first step into the world of microprocessors, the brain behind the most modern technology we are going to discuss. This course is common to EEE students and ENA students under the BE program. And today's topic is an introduction to microprocessor, the first lecture of microprocessor and microcontroller of the course. Here's what is the learning objectives, learning outcomes, introduction to microprocessor, history of microprocessors, basic block diagram of microprocessor, basic terms, or I can call it as important terms what we are using in microprocessors, summary. We will start with our goals for this session and we continue the learning. The microprocessor learning objectives are, in the real time, you can understand the first one by end of this session. You should be able to understand the basic concept of a microprocessor and its application. A real time how we are using and computing and controlling the mechanism by using microprocessor. And we will discuss the component and their functions, the basic terms what we are used in the architecture and operations, and historical development, the recall its history and evolution, and identifying the main components. And of course, we will recognize some of the important terms that make you to understand the definition of what is microprocessor. Recognizing the basic technical terms, these objectives help us stay focused on the core idea. So this is the learning objective of our today's session. And after this particular session is over, you will be able to have some of the way from this particular session. You can define what is a microprocessor, and you can describe what is its process, and you can able to give the classification, applications, and you can able to summarize the history or the generation of microprocessor, the block diagram. You can able to label it, and using a correct terminology when we're talking about microprocessor, you can define the key terms easily. So by defining the key terms, you will understand the fundamental concept and terminology. Okay, when you are having these are the course outcomes once the session is over. A microprocessor is a brain of the computer that has been implemented on one semiconductor chip. Understand it is one of the semiconductor chip, so it is a programmable device, a programmable chip that may do some of the mathematical operation like arithmetic operation, logical operation. That program is going to stored in a memory and it will produce some results. So this is what we can moving for your microprocessor definition, exactly be close to the microprocessor. Now I can purely say in a technical term how we are defining your microprocessor is. A microprocessor is a multi-programmable, a clock-driven device or a clock-driven register-based semiconductor device that is used to fetch, process and execute. Fetching means we are going to inserting, giving some orders or giving some command, and process, it will manipulate what are the process you want. Definitely it will perform, that is execute a data, that is our binary data. Execute a data within a fraction of second. Here I can say the micro, the meaning of micro. So within a fraction of second, a particular process or a microprocessor is a multi-programmable clock-driven register. It is nothing but a simple semiconductor device that is used to fetching our program coding or fetching our commands, fetching our instructions, and that will process and execute the data within a fraction of a second. This is, I can say, the exact definition of microprocessor. The basic block diagram of microprocessor system. So now we will understand the definition. So we may have some of the system that consists of a memory unit, that consists of arithmetic and logical unit, and that also consists of to process those things, and we're going to drive something. Definitely it look like a complete computer, or I can say a CPU. So now we have this block diagram, looking into the block diagram, and this is a particular important block diagram system. So now this block diagram is called a heart of a microprocessor system. Here I am having the central processing unit. We have a CPU. In that CPU I am having some control unit are there, some arithmetic and logical unit are there, a primary storage unit, that is a memory unit also there, and some of our input devices, some of our output devices, and secondary storage device also there. It's look like a small computer. It looks like a computer. In arithmetic and logical units, we will perform a lot of mathematical and logical operation. Like you can say the example of mathematical operation, you want to do adding, you want to do some addition, subtraction, and you want to do some ascending order and descending order, and you want to make an increment and decrement. Okay, some of the logical operation, I will give you some example. Like we will do some addition. Instead of that, we will do some AND operation, OR operation, XOR operation, NOT operation. Okay, and some of the logical combinations we can have for greater than, less than, equal to. Okay, some of the comparison also we are going to do. And some of the control units, so it can direct the flow of data as per your instruction, right? And also it will fetch, we can fetch the data into your particular system, that can able to making a control of all the parts where the data should be flow. And the registers, those are having a temporary registers that can able to fast data accessing purpose. So we are using for accessing purpose. And we are also having some of the buses to interface all this connection. You want to connect a keyboard, you want to connect a mouse, you want to have an output device, a monitor should be connected. Some of the disk and tapes and optical device, secondary storage device also connected. So to connect this, we need all the collection of wires that we called as a bus. So here we are having some bus that also making to understand how we are connecting to your CPU system. So this is, I can say, a block diagram shows, the complete block diagram shows the heart of microprocessor system, which consists of ALU, control unit, and some of the registers, a memory unit, input device, and some of the output device. So this is a basic block diagram of the system. So the core of the computer architecture. So here the block diagram will show that is a core of your computer architecture. So here we have a CPU structured based system. I already told it consists of three different kind of units. One is arithmetic logical unit, control unit, and this memory unit. So the CPU is divided into these three main components. So it is look like a complete CPU structure. Definitely we will have some storage hierarchy. The system includes both the primary and secondary storage for immediately accessing your data. And this diagram represents the computer architecture with the interconnect of all the components, like your input components, like your input devices, output devices, keyboard and mouse, monitors and display unit, and some of the units having the data flow combinations, and we have the directional data transfer flow. The data can be read, the data can be written, the data can be used to communicate something. So we are going to transfer those things by using some of the cables or some of the bus connecting wires. So I can say a core computer architecture, we call it as a complete microprocessor system. What are the application of microprocessor? Now we understand what is microprocessor. Now we will looking for what are the applications. We know that if you want to do any manipulation, storing some data, and we want to retrieve some mathematical operations, and we have to take and dividing some functions, that and all we are going to come to the cross of calculators. The calculator is one of the best example and application of the microprocessor, which will perform in a microseconds. Whatever we are going to give or inserting some data, typing some data in your calculator. Let me take some numbers of 5 into 2, which is equal to 10. These data can be easily fetched into the microprocessor, that is your calculator, and it read all your data to be fetched inside it, and it execute it. It will do some process, and it will execute it, and it shows some result. So this is exactly one of the best example of your microprocessor is a calculator. Like we have a lot of applications of your microprocessor: an accounting system, gaming machine, instrumentation, traffic light control, multi-user, multifunctional environments, a military application, communication systems. These are the application of your micro. So now we will move to a microprocessor history. In previous we discussed microprocessor. So we have a generation of microprocessor. Since it's evolved from an year of 1970s, we have first generation, second generation, third generation, fourth generation, fifth generation, sixth, like it going on. So I can classify this microprocessor evolution according to the size of the bit. I can say the first generation is a simple 4-bit microprocessor. Like Intel already generated it, and Intel we call it as 404. This is a first simple 4-bit microprocessor. So the first generation microprocessor IC is a 4-bit microprocessor. The second generation 8-bit microprocessor. A third generation 16-bit microprocessor that will handle 32-bit numbers, 32-bit IC size, and 8-bit processor will handle the 8-bit data. And the fourth generation, so now we are in the moving of a 32 and 64 is a bit of process. Now we are having the fourth generation, which having a multi-core CPUs. So still it moving forward or moving ahead of all the evolution. So every generation, in every generation, the first generation, second generation, third and fourth generation, they are manufacturing their ICs and introducing the ICs based on some of the factors. That is, every generation improved speed of the IC, that is the speed of the microprocessor, power and efficiency. So these are the things are keep on improved in the generation of ICs, and that also enabling today's the smartphones and that supercomputers are evolved in this the history of microprocessor. Of your development of microprocessor, the family of Intel. Now we people are in the Intel 1, 2, 3, 4, 5, 9, 11. So like this 7, 9, 11. So like this we can have a lot of implementation developed in the micro, and these are different processes available based on their socket, based on the structure of it. So now you can see in your CPU, you can see in your CPU there is a computer. In your computer CPU you will see the socket like this, and you will have the processor which consists of pins and pinless, like a rectangular box, a small semiconductor chip, and you have some slot of processor also. You can see that also in the classic of 19 years of the computers, we have these type of a socket and processors, and that also going to adopt in a different kind of availability. So we can say these are the different kind of package systems are available. Introduced in 1971. This is the history of microprocessor. In 1971, the Intel they start launching the first microprocessor. The name it is called Intel 4004. It was a 4-bit microprocessor. This is the first generation IC. It consists of a 4-bit data handling IC. So it was a 4-bit microprocessor. So the clock speed is very smaller, 740 kilohertz. So it can operate the maximum speed of 740 kilohertz, and it had a 2300 transistor inbuilt in it. We already know the scale of integration of any integrated circuits consists of an n number of logical transistors, and flip-flops and counters are there. So in this particular IC we will have a 2300 transistors, and it could be execute around 60,000 instructions per second. 60,000 instruction per second. And the next one, it is a 1971. It was introduced in Intel. We call it as an 4040. It was also a 4-bit microprocessor. Then now we will move to an 8-bit microprocessor. So in the year of 1972, the Intel introducing 8008. It was a first 8-bit microprocessor. The clock speed was 500 kilohertz. It could execute a 50,000 instruction per second. And the next one, in the year of 1974, the Intel launched the IC called 8080. It is also an 8-bit microprocessor. The clock speed is little bit increased at 2 MHz, and it had 6,000 transistors. And this is one of the very important, and this is our IC 8085 microprocessor. In the year of 1976, Intel introduced the Intel 8085 microprocessor. It was also an 8-bit microprocessor. The clock speed was approximately equal to 2 to 3 MHz. The data bus here we are having 8-bit, and the address bus we are having a 16-bit. I will tell you the meaning of address and data bus later. It had a 6,500 transistors in it, and it could execute nearly 8 lakhs instructions per second. It could be accessed at 64 KB as an internal memory. It had a 246 instruction. So this is our IC. This is what we are going to study as a fundamental IC. This IC having some of a standard specification that we call a spec. The spec is going to meet some basic requirement and all. That is why this IC we call it as in an 8-bit microprocessor. This is a fundamental IC. The name is Intel 8085. So we will see some of the 16-bit IC also. 16-bit microprocessor. So 8086. It is in the year of 1978. It was the first 16-bit microprocessor. That's why the data handling capacity is a 16-bit processor. The clock rate is 4.77 MHz to 8 MHz. And also it is available to 10 MHz depending upon the version. Here we have 8086A, 8086V. Like this we have a different kind of versions are there. And the data bus is 16-bit and the address bus is 20-bit. It had a 29 transistor inbuilt in it. It can execute a 2.5 million instruction per second. We can also access the internal memory of maximum of 1 MB of memory. It had 22,000 instructions we had, and it has a very important feature of a direct multiplication and division instructions are available. So you can able to do a 16-bit multiplication and division directly by using some instructions. And the next one, in the year of 1979, the another 16-bit IC was introduced. We called as Intel 8088. It is created for the very cheaper version by the Intel. It was a 16-bit processor with the 8-bit external bus. The next one, Intel 80186 and 80188. It is also introduced in the year of 1982. They were 16-bit microprocessor. The clock speed was 6 MHz. And 80286 in the year of 1982 it was introduced. It is also a 16-bit microprocessor. The clock speed was 8 MHz, a little bit improvement from the previous version to this version. The data bus is 16-bit data handling and the address is 24-bit. It could address a 16-bit memory of an internal memory. It had a 1,34,000 transistor inside it. Now we will see some of the examples for 32-bit. And here the 1986 we had another Intel 80386. It was a first 32-bit microprocessor. It could address a 4 GB in the internal memory. We can have it had a 2000. It has a 2,75,000 transistors inside it. The clock speed is totally changed from 16 megahertz to 33 megahertz depending upon the version is available in the market. An Intel 80486, and this is also a 32-bit microprocessor in the year of 1989. 1.2 million transistors are there. A 16 megahertz operating speed to 100 megahertz depending upon the various version. And 8 KB of cache memory was introduced. Here we have some virtual memory is also. And the Pentium family slowly come to the picture. It is introduced in the year of 1993. It was also a 32-bit microprocessor. The original it is named as 80586. The clock speed was 66 megahertz. And it has a data handling capacity is 32-bit and the address is also 32-bit. And the next one is Pentium Pro. It is introduced in the year of 1995. It was also a 32-bit microprocessor. It had a 21 million transistor inbuilt in it, and it has a cache memory of 8 KB instruction and 8 KB for data. And Intel Pentium 4, and this is introduced in the 1997. It is also a 32-bit microprocessor. The clock speed was 233 megahertz to 500 megahertz. So now when we are keep on come to for an upgradation of a 32-bit and it go for 64-bit, and of course the speed rating also is also increased. The number of instruction executed per second is also increased. So here that 333 million instruction can be executed per second. This is Intel Pentium 2. So we have introduced on 1998 32-bit microprocessor. It is mainly designed for a server application. The clock speed is 400 megahertz to 450. And Pentium 3 in the year of 1999, 32-bit microprocessor. The clock speed is 500 megahertz to 1.4 gigahertz. And it had a 9.5 million transistors in the processor. The clock speed is 1.3 to 3.8 gigahertz. It had a 42 billion transistor in it. It was introduced in the year of later 2000. We have 2006. There is Intel dual core was introduced. It is a 32-bit and 64-bit microprocessor. So now we are having a 64-bit microprocessor. Some of the examples we are going to discuss 64-bit because today we are not we are using a 64-bit microprocessor based system only we are using. And in case of if you go for supercomputers and anything, you can go for 128-bit extra. The 64-bit processor, we can have a two important brand. One is Intel Core 2, Intel I. So these are a 64-bit microprocessor, and that plays a very important role in the today real-time application. All your computers and different kind of electrical applications, electronic application and all. And before we go for a microprocessor session, we discuss what is microprocessor, the history of microprocessor. Now let's quickly go through some of the basic key terms that we are going to keep on used in this microprocessor, because we can take in some of the references from our prerequisites and we will define those are the terms and we will go for it. Let me talk about the instruction set. It is a language of microprocessor is going to understand. Instruction set means it is one of the programming language that the microprocessor can able to understand. Clock speed, how fast it process the instruction, how much it can able to process the instruction very fastly. The word length, how many bits can be handled in one go. For a second of one particular transition will take place, how many bits it can handle. A bus architecture, definitely we should understand the layout of communication lines. A memory addressing mode that can able to access your data memory and program memory. So these are the basic terms you should know. From this, some of the fundamental terms you should be recalled frequently. You should know what is a bit. A bit is nothing but a digit of binary number, zeros and ones. A nibble is nothing but a 4-bit is equal to 1 nibble, 8-bit is equal to 1 byte, a 16-bit equal to 1 word, 32-bit is called as a double word. So here some of the important terms we are collecting from our digital logic circuits. Please refer this also. And we call it as a data. A data is nothing but a binary number or a code that operated by an instruction. Address. Very important, the term I am using in this particular microprocessor course. I am telling the address. Address is nothing but a memory location. The identification of memory location. So suppose if the data is stored in your memory, so how we can locate it? By using address. So clock speed. So a square wave is used to synchronize the various devices in the microprocessor. So we should know what is a clock speed, and the memory capacity is nothing but 2 to the power n. N is nothing but a number of address line. If I am saying one clock period, we can see the clock width, and the clock width is going to speak about during your on time and during your off time, and we can have a rising edge and falling edge. So this is how we are representing the clock period. Please refer the diagram. And some of the bus concept you should understand. The bus concept is clearly, I can say, it is a collection of wire, a group of conducting lines that carries a data, address and control signal. So here all the wires here we called as the bus. The data bus is a group of conducting lines that carries only the data. The address bus is that carries only the address, where your data to be stored, where is your data available. So that and all can be conducted in the line we call it as a address bus. The control bus, the grouping of conducting lines that carries a control signal. Suppose if the data is going to making, you can able to read, you can able to transmit, you can able to receive. Sometimes you may go to read and sometimes you may go to write the operation. So both the things are controlled by control bus. Apart from this, we have two bus. One is CPU bus, a group of conducting lines that directly connect to the CPU. A group of conducting lines that carries a data, address, control signal in a microprocessor system is called as system bus. A group of wire that directly connect to microprocessor is called as CPU bus. A group of conducting lines that carries a data as well as address and the control signal in a microprocessor system, we call it as it is a system bus. So these are some of the fundamental basic concepts from your basic of digital electronic circuits and integrated circuits as well as the electronic device and circuit. The next one, the very important term, is a tri-state logic. So there are three logical levels out there in your microprocessor. We are already aware. One is a high state, another one is a low state, another one is a high impedance state. When we called about a high state, it is a logically 1. When it is called as a low state, it is a logically 0. When it is a high impedance states, the output is not being driven to any defined logical level by the output circuit, because we can't understand which is going to happening during your high impedance state. Okay, so the output is not being driven, we cannot operate anything on it. So let me take, it was our first look into the world of microprocessor. As you now you can see, they are all just a part of computers. As you can see, they are all not just a part of a computer. They are everywhere around us. I am not saying computer is a microprocessor. They are not just a part of computers. They are everywhere around us. So try to understand the definition of microprocessor once again. You can go through the video again. In the upcoming session, we will explore the architecture, block diagram, instruction set and the programming in detail. Remember, every great system starts with the understanding its brain, the microprocessor. Remember, every great system starts with the understanding its brain called the microprocessor. So now you can able to understand a clear clarity on what is microprocessor in this session, and the remaining we will see in our next session. Thank you everyone.